Welcome back. Let's do question 5.3. Determine the general solution of the following equation: cos x plus 2 sine x times 3 sine 2x minus 1 is equal to 0. Right, before we do this, I want us to discuss a few things. There are actually two ways to get the general solution, but I prefer this one. And I would like you to try and learn this one because it is very, very easy. Right, remember that when you're using our curve diagram, at the first quadrant, we have our acute angle theta. Let me use theta, or you can say x if you want. And then in the second quadrant, we have 180 degrees minus theta. And then in the third quadrant, we have 180 degrees plus theta. And then in the fourth quadrant, we have 360 degrees minus theta. Please remember that. Right, and then to get your general solutions in quadrant 1, just remember that we say theta is equal to our reference angle plus k times 360 degrees, where k is what? Is an integer. And then in quadrant 2, this is quadrant 2, we have 180 minus theta. So it's going to be 180 minus reference angle. So in quadrant 2, just know that your theta is going to be 180 degrees minus your reference angle, which will be your calculated angle, and then plus k times 360 degrees, where k is an integer. Right, quadrant 3, we have 180 plus theta. So it's going to be 180 plus the reference angle. So theta is equal to 180 degrees plus reference angle plus k times 360 degrees, where k is an integer. So if you remember the curve diagram, it becomes very easy for you to remember these general solutions. And then quadrant 4, this is quadrant 4. Quadrant 4, we have theta is equal to 360 degrees minus reference angle. Our theta there is the reference angle plus k times 360 degrees, where k is an integer. Okay, so remember this. Once you remember this, then you're fine. Right, let's come back to our question. So we have two factors here. This bracket times this bracket to give us 0. So it's either cos x plus 2 sine x is equal to 0, or 3 sine 2x minus 1 is equal to 0. Right, let's start with this one. Right, so we can bring 2 sine x to the left hand side, becomes cos x is equal to negative 2 sine x. Now with sine x and cos x here, we can divide both sides by cos x so that we can get what? We can get tan x. So divide by cos x, divide by cos x. And then get that 1 is equal to negative 2 tan x. And then we can divide by negative 2 on both sides of the equation. We get tan x is equal to negative 1 over 2. So now let's get our reference angle. You say arctan x is equal to arctan, or inverse of tan, and then negative 1 over 2. And then what we get that x is equal to negative 26,5655,05118, right, degrees. Now, this sign of your angle will assist you to identify the quadrants. Tangent of an angle is negative where? It's negative in the second quadrant and fourth quadrant. So it means we are going to use this one and this one. And then when you're using this, just ignore. Just say 360 minus 26, 56550,511. Ignore the sign. Use the sign to identify the quadrants. Then after that, just ignore it. Okay. We have our x is equal to 180 degrees minus 26, let's use 2 decimal places. So 57 degrees, and then plus k times 360, and then where k is an integer. Okay, then we can simplify this. Then we get x is equal to 180 minus 26,57. We get 153,43. 153,43 degrees, and then plus k times 360, where k is an integer. We have one of the equations that we need, just one of them. Let's go to the second one, the fourth quadrant. So it's 360 minus reference angle plus k times 360, where k is an integer. Our reference angle is 26,57. So it's going to be x is equal to 360 degrees. We're using this one, minus our reference angle, which is 26,57. Said when you're subtracting, just ignore the sign, and then becomes the sign of this sign. Ignore the sign when you're subtracting there. And then plus k times 360 degrees, where k is an integer. Then we can simplify this. X is equal to 360 minus 26,57, that is 333,43 degrees, plus k times 360 degrees, where k is an integer. Okay, so that's the second one. So you're done with this part. Now let's come to the second one. Let's erase this to create space, but remember these four. Remember these four. We have 3 sine 2x minus 1 is equal to 0, meaning that we have 3 sine 2x is equal to 1. Divide by 3 on both sides of the equation. Sine 2x is equal to 1 over 3. Right. And then we have to find our reference angle. We have to calculate our reference angle. So what we do, we arc sine. So we're finding our angle is 2x here. Okay, we're finding 2x. 2x is equal to arc sine 1 over 3, meaning that 2x is equal to what? Is equal to 19,47122,063. So use this as 2x, or referencing this 2x. So it's positive. And then sine of an angle is positive in the second quadrant and in the first quadrant. Okay, that's why sine of an angle is positive, because this is positive. So the first quadrant, we have the first quadrant is going to be 2x is equal to 19,47122,063 degrees, and then plus k times 360, where k is an integer. Right, so we divide everything. Now divide everything by 2. So it becomes x is equal to 19,47122,063 divided by 2 must give you roughly 9,74 degrees. And then plus k times 360 divided by 2, 180 degrees, where k is an integer. Okay, see that? That's the third one. And then also we said it can be in the second quadrant. So we have the second quadrant one, 2x is equal to 180 degrees minus our reference angle, minus 19,47122,063, and then plus k times 360 degrees. Okay, 360 degrees, don't forget that. And then k, where k is an integer. Right, and then if you simplify this, you'll get that 2x is equal to 160,5287794, then plus k times 360 degrees, where k is an integer. Then we divide everything by 2. So x is equal to 80,26 when rounded off to 2 decimal places, plus k times 180 after dividing this by 2, where k is an element of integers. Okay, so that's what you're supposed to do there. So these are the answers. We have 1, then we have 2, we have 3, we have 4. Okay, so it is this or this or this or this. That's what you're supposed to do there.